Hello, good afternoon, everyone. Welcome to the second day of the session. I think we all can begin with the presentation now. Govind sir, we can begin now if you're ready.
Yeah, yeah, yeah.
Okay, thank you.
Yes,
Yes, sir, we can see.
it's audible.
Yes, sir.
Fine. You can see my desktop.
Yes, sir.
You can see my desktop.
Yes, sir, we can see it's visible.
Fine. Yeah. Today, our topic is regarding the surface modeling or the surface design. We are using CATIA. You can use the different software. You can use the other softwares like Unigraphics NX. You can use the another software SolidWorks or Pro Engineer or the surface design also. But a CATIA, they have given very easy steps to create the three-dimensional surface design. What is surface? The surface is a smallest division of x and y patches generated between the different non-linear curves. These are the smallest division of x and y patches between the non-linear curves. And to create the surface model, we need to go for the wireframe geometries. The wireframes. First, we should know how to create the different types of wireframes. That is, the points, the 3D points, three-dimensional points, and here. How to create the construction element for the wireframe geometries. We have to go for the different types of surfaces. Before surfaces, you need to go for the creation of different wireframe geometries. Let us see how the models are going to develop. I am audible, sir? Hello?
Yes, sir.
No problem with the voice, no?
No problem, sir.
Fine. Let us go ahead with the one new file. Initially, I go ahead with the part design only. There we are going to create some applications-based concept. Means just I create a rectangle, the another rectangle, and circle I would like to create here. You can go for some round applications like that. And then I go for one pad, around 20 units. Okay. If you go for start mechanical design, wireframe and surface design, you are entering into a different workbench. How to understand the workbench? You need to keep the mouse in this position. You can understand on which workbench right now. Presently, we are working with the wireframe and surface design. What are the basic commands? You can get all these things for inserts here. First, you need to go for the points, point sets, line, axis, polyline, projection of the curves, then intersection of the curves here. Then we have the three-dimensional wireframe geometries. You are going to get these things in sketcher mode also, here also. But the only thing is that but you are working with the 3D concept here. All these things are 3D concept, and then you can convert into a surface design and surface operations. And these are the additional applications for the surface design. The sketcher, this is the sketcher. With the help of here, you need to require one reference plane to create any type of wireframe geometry, that is the curves. But whereas if I go here, it's not going to ask any point. You have one point at sketcher mode also. This is a point. This is also one point, but it requires one plane to define it. Okay. Whereas here it requires, these are the 3D points. The toolbar name is reference elements. First I go ahead with the point option. Here, to create the point, you need to have different concepts. First one is the coordinate system. Suppose I would like to create one point from the x 100, y 100, and z also 100. Yeah, we got one point here. We got one 3D point. This is 2D, this is 3D. And you have the other options also. Here, how we require points. Now, we can create a line between any these type of objects here. Here, isn't it? We need to create. And why I need these two? To create plane, I can pass my plane between point and a line option. Between point and a line, it is asking select a point and then line. Here, we got a passing through this. To create any object, you need to have certain planes generally. To create parameterized features, parameterized sketches, you need to create wireframe geometries. Then you can create the planes. With the help of these concepts, we can go for the creation and modification of wireframe. Those can be converted into a surface design, and further it will be utilized for the solid modeling. Clear? Let's one by one we'll study fast what are the different types of options to create the points also. Next option, on curve. See here, you have the on curve. You can give the value. If you know the value, you can give. You can go for the midpoint also. You're going to get the 3D points. Here, you're going to get the 3D points. You can go for the wireframe. Okay. In hidden mode. And next I go for the on plane. Suppose I have one plane here. We're going to get a plane. The point passing through plane here. These are the on plane options. Next, on surface. Suppose I have one surface here, and I can create wherever I would like to have it. This is an on surface option. This is on surface creation of the 3D points on surface. Circle of sphere center. This is a circle. At the center, you are going to get it. Here also, you are going to get the circle of sphere center. Next, tangents to curve. Add tangential to this curve at this position. You are going to get tangential point. This is a tangential point. You can see the points. Next option, you have the between. I would like to create a point between these two. You can go for the midpoint also. Here. So, like that, we can create the different types of points. Then you have the line options. I can create a line between any 2 points. Next option, point and the direction. This is a point and this is a direction. Here, we are going to get a 3D points. Next we have angle normal to curve. What is the requirement? This is a curve, this is my curve, and this is my point. And support. Suppose this is my support. Here, angle or normal. Normal is perpendicular. Normal, or you can create the angle like that. This is a 3D lines. These are the 3D lines, can be utilized as axis also. Tangential to curve. Suppose I have one tangential reference here or somewhere here. I don't it is asking point. I don't have the point. I go for the creation. I click, go for the creation of a point. On curve. In that again, I'll go for the option called on curve. Again, click here. Here. Now I create here. Means we got one point. They are tangential to this circular curve. At this position, we are going to get a tangential line. It's normal to surface. Normal to surface. This is a surface. At this point, you need perpendicular. Normal is always perpendicular, like that. Next, you have bisecting. I would like to bisect a line between these. You have 4 options. It can be bisected both options. Red one is accepted. Either you need this or this. This one I want to keep it here, like that. Next, you need to create the planes. Default option is a offset. You know this one. This is a offset plane where you can have the distances. Next, you have parallel through point. Parallel to this point. Here. Parallel to this through this point. Parallel to this through this point. Here. Parallel to point. Like that. Because we need the place having a working area having infinite length and width always. The size can be increased, but generally it is going to disturb if you increase the size. Then we can go for the angular plane. I would like to keep the angular plane as a rotational axis, this one, at 60 degree. See preview. Here. We got one planes at 60 degree. The angle can be customized here. The angles can be customized as per your requirement. Here. Like that. Suppose if I make one hole, here, I go to sketch, just I create one hole here. I make one pocket, or directly you can go for the extrude here. Here, you go. That's it here. Means the plane is having infinite length and width always. It can be increased as per your requirement. It can be increased. Okay. And next we have three points. My plane, I would like to pass this through this point, through this point, and through this point. Here. Suppose if I go for a split, whether it is passed or not, to understand it, you need to go for the split option. Split with respect to this plane. Here. Here. It has passed. I have selected this plane to create the 3-point plane option. So we got that plane passing through these 3 points like that. Either you can keep this or you can keep the opposite one also. Here. This is passing through these 3 points. You can see. You can see. Again, I go to wireframe and surface design, and also you can go for the advanced surfacing. That is, these are all surface design applications. But in that, I would like to select generative shape design (GSD). Generative shape design. Additional commands you are going to get here. Additional, the same thing with different new concepts you are going to understand it here. Next, plane through 2 lines. Suppose this is my line, this is my another line. It is passing through 2 lines. We got the plane. Next, through point and line, I have shown you through planar curve. Suppose this is my curve at this point or at this point. You would like to plane means on which plane it is, it will comes. Normal to curve means on this curve at this point. We got a plane passing through these points. Next, tangential to this surface. This is a surface at this point. If I don't have the point, you can create a point at the middle. We got a plane. Tangential here. Tangential to that surface. Next we have equation. Also you can go mean through points. Suppose if I have any 3 points, here, mean through points. Like that, you are going to get the different types of points as per your requirements here. With these concepts, you can work on the different types of surface designs. Okay. What I do, I go for the hide all curves. I would like to hide right now. Hide all points. Hide all lines and planes also. See, only we have 1, 2 curves and part design. I hide this part also, these 2. So these are the three default planes, which is called specification. So the tree includes whatever the operations we are going to create here. It is going to include in the workbench. Now what I do, go to sketch. I think you are getting. Yes. Hello.
Yes, sir.
All are hearing, na?
Yes, sir. Yes, sir. Everything's fine.
Fine. No problem. So basic things I will explain, then I'll go over the further things.
Okay.
Basics are very important for the applications. Fine. Let us, I go ahead with the one, two curves. Here, I have created one sketches. See, these are the commands, extrude options. First one, extrude option is there. Suppose if I select any closed object, it is a closed one. Here, we are going to get a surface. Surfaces, as I have told, we don't have, right now we don't have thickness. We can give the thickness. See, it is a closed section, perpendicular to the defined sketch. Suppose if I select this one, see the same command, extrude only. Yeah, you can see here. The direction. I can change the direction also. Suppose if I give this vector direction, it comes like this. If I know the 2 points, or if I create a line, again 2 points. Suppose if I select this point and this point as a vector direction, the extrude it will be like that. Depending upon the user requirement, how you are going to define. Otherwise, it could be perpendicular to a defined sketch. Suppose if I extrude this surface in the direction, okay, it is closed surface. It is a closed body. It is a closed body having single entity. Okay. Closed section, open section, closed section and open section, and close the surface. If I give surface, suppose if I extrude this edge in this direction, there also you are going to get the material is there here. Like that. In extrude only, we can utilize while creating the surface design. We can utilize according to your requirement. Surface, as I told, these are a hollow application. Suppose if I split this one with respect to this plane here, flip direction is hollow. You can flip with these directions also. Here, I can split it. Here, it is hollow. Again, you can split this also. This surface with respect to this plane. Here, surface is hollow. Okay. And the same thing can be utilized for the revolving applications. Next command you have revolve. Suppose this is a section, or this is a section, this is an axis. The angle can be customized. Suppose if I select the open section here, if I select this axis, it comes like that. Again, it's also revolve. Suppose if I revolve this surface, it will be again, I extrude it first. Suppose if I revolve this one, closed entity. It is again closed entity. Okay. If I revolve this edge, see, like that you can create according to your requirement. Like that, you can go for the creating one sphere. Full sphere, semi-sphere. Sphere, okay, and full sphere, semi-sphere. The length and all things can be customized here. These are some basic important to go for object. Different, different. Copy you can copy. this point to point direction, from this point to this point. Copy is different. Means copy means it will be the same section. The offset means it is going to curve, is going to form in surface straight edges like that. There is a difference between both the things. Next, suppose I would like to sweep one section along with this curve. So I go for create one plane normal to this curve. In this edge also can be utilized as a perpendicular curve. I go here, or you can create a sketch also. You can coincide the 2 points. Like this. You can sweep. So many options are there in sweep. The important is sweep along with this guide. Sweep command. The section is stuck. Both are not joined. Those are independent entity. Okay, those are not joined. And like that, you have multi-section. It's very important command. And before that, I would like to extract the curves from this wireframe geometries. I would like to extract the curves from this wireframe geometries, and here there is a command called extract. Sorry, I would like to extract the curves, extract the edges. No propagation. Point continuity means all the edges are going to extract. Hide it. The curves are there. Curves are extracted from this. These are a single entity. Extraction is single entity. I have to disassemble to make independent entity. Here, I have made disassemble. So I have to go for disassemble. The last command. Here, these are all independent. Now I go for the height. I would like to fill the material. I would like to fill the material between these sections. First section, second section, third section, and fourth section. See, it is a fill. How it comes. It has got different. It will not come like that. It will not come like the sphere. Whereas if you go for the multi-sections, if I go for the multi-sections, you have the different sections. And with two guide curves. This is my first guide curve. This is my another guide curve. Here. Clear? See, like that, it's correct one. Multi-sections, it requires minimum 2 guide curves. You can go with this spline, coupling, limitations options. According to your requirement, you can plan it. Next, and extrapolate, extending the surface. Extrapolate, you can rotate, you can copy it. You have some sub options also. You can rotate, copy, mirror, symmetry, this with respect to this plane. Like that, you can go for a symmetry, and so many sub options are there. And you can go for unfold, any surface, fold, unfold, like that, according to your requirement. Further, suppose you would like to create some additional application sketches like that. You have the curves, the isoparametric curves, so important. In the interview, they are going to ask generally isoparametric curve. And you have helix, spiral. Let us see with the isoparametric curve, how it works. Here. How the curve shape is there, it is going to create here. Here, like that. Even though on these curves, suppose if you should like to split it, you can use it according to your requirement. Okay. Like that. And there is a command called split. In that split, you can modify the surface design. Split and trim options you have. I go ahead with the split. I would like to split this with respect to this, and also with respect to this. Can use two applications also, and again this with respect to this plane, okay, like that, and this one with respect to this curve, okay, like that. The objects can be split as per your requirement, and here also this curve, uh, like that. You want to split this with respect to this, you can do it. Means you can modify a surface design as per the requirement. Suppose if you want to create a surface between these two curves, you have to go for multi-section. This is my first curve, this is my second curve. What is my intention? To create surface design, you need to go for the creation of wireframe geometries. To create the wireframe geometries, you need to go for the reference elements, the planes, points, lines, like that. According to that, you can plan it, then you can create objects your requirement. And also, it can be converted into solids also. Suppose if I have one sphere here, I would like to create one sphere. Suppose you want to create a complete solid application, or okay, you can create solid applications. And before that, if you want to go for giving the fillets, suppose I want to join these two. Now it is joined. Edge fillet option. These are the shape fillet. Shape fillet means between two surfaces. You have to keep the direction, give the fillet here. Give one 15 mm fillet. Here it is going to form the tendency. Let us see. Okay. We go for the edge fillet option. The edge fillet. If we have the two applications, fillet. Here. Smoothness. Surface fillet. Surface fillet applications. Like that. Now, hide these things. I would like to extend, extrapolate this surface with this curve. And again, I would like to extrapolate this surface in this direction. And here also. Extrapolate this. 50. You can give more also. So 80 it is not taking. You can plan like that, something. No, 60 also. Only 50 it is taking. No problem. Like that. See. Means you can cut it, you can create it according to your requirement. Like that, you can extending the surface as per your requirement. Single entity. Now I go to part design. I go to part design. I would like to convert. I would like to convert solid to surface. See here, there are commands like thickness. We can add the thickness. We can add the thickness for these surfaces. Inside 1 mm or outside 1 mm. Inside 2 mm, outside 2 mm. See, it is hidden. Show it. 1 mm. 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 1 Okay, solid. The solid thickness we have added it. Okay, here also we can add. It is a we can go for the closing entity. So we can convert it into a solid. So hide the sphere, solid. There. The solid model can have the sections so that we can understand it is full of material. Can have it is having full of material. Isn't it? It is full of material. Now suppose if I give thickness instead of this close, if I give thickness, I hide the sphere, surface sphere. I go for the thickness, adding thickness inside to mm, outside to mm. Again, if I take the section here, because we are given the thickness for the surface, we are given thickness like that. You can split the surfaces with respect to these planes. Surface, inside surface is there. Here. Now again I go to surface design, wireframe and surface design. I can extract the surface from the solids. There is a command called extract. I want to extract the surface, this surface, in that only single surface, no propagation, single surface. Here. We have extracted the surface. Even though we can extract the curves, we can also extract the curves from the solid body. This. We can extract the surfaces. Again, this cylinder surface. This. Now the point continuity is different. Complementary means the opposite surface. The star surface you are going to extract here. All the surfaces. Like that. Extraction is done here. Like that. If I hide the solid, all surfaces are there. According to our requirement, these are some basic commands of the surface design. Then here, how this model has made. With the help of wireframe and surface design, the model has made. Let us see how we have done this one. Yeah. The basic sketches. Yeah. Surface, move along with the path. You can see the tree also. You can see in the tree also. Then we have developed means projection. Means projection of the curves according to our requirement. Yeah. Then we have made concept applications. We have made the blend between the different commands. Then the opposite side. Yeah. With the help of wireframe and surface design, you can add the models, you can create the models, or you can create and you can convert into solids. Then you can move along with the part like that. Single object can be visualized in all the viewports. Front view, top view, side view, isometric view, all the parameters you can visualize according to your requirement on material, without material, like that. Then have the sections here also. What you can have the sections. Suppose the mouse part here. To make the another part, mouse part, we have used hybrid design here. This is also one of the top cover of the mouse. Then the not new one, the older mouse, like that. How we have made? You can cross verify. Okay. First we have created the three curves. You see the three curves. Then we have made the first wireframe geometries. First we have created wireframe geometries. Then they are converted with the help of multi-section surface between three guide curves with two paths. First guide curve, second guide curve, third guide curve, and two paths. If I double click here, you can see here two sketches and three paths, three guide curves, two sketches, like that. Then we have made the cutout. So what is the requirement for to development of the mouse like that? It is not required. We started removing the material in surface only, and at last we added the thickness, wireframes, surfaces. Then it can be converted into solids. Yeah. Different approaches can be given. Different approaches can be given, and you can make according to your requirement. Whereas for this applications, we have made cut approach. We started with the part design, then we have made a cut hybrid design. We have developed the hybrid design product. Just we have made one rectangle. The cut approach for the modeling. You can go for the sheet metal applications. You can use the cut approach. You can create the model through surface approach. You can create the model through shell approach. I show another example for the shell sheet metal design. There you can go for the different concepts. Here, what is not required for our model, we are removing. We started removing cut approach here. Then wireframes. Then we have made the wireframe geometry. Here. Then surfaces. Then surface. Then again hybrid design. Wireframe 3D points, 3D lines, 3D planes, and then we give the thickness. Then we have removed the material, add the material according to our requirement. Here. Like here. Isn't it? We cut the most part. And if I go for the shell approach, here, shell approach, the modeling done through shell approach. Here, the shell application. And the sheet metal design through part design. They create the sheet metal also. Here, the model. So it is Indica vehicles lever lock. The car doors lever lock. Okay. At last, shell we have made. Shell. This is before the feature you have to define it like this, and at last we have to define our requirement like that. Shell approach. Sheet metal design. Sheet metal design application. Here, CAD has got more than 110 models here. So many models are there. These are all surface applications. Automotive class A, class B surfaces. This is also surface design. Sketches. Freestyle. Freestyle is surface design application only. Freestyle is also surface design. But generally, you can create the different surfaces, control points for options, 2 point, 3 point, like that. Different applications we have. You can get all these surface creations, 3 point applications, 4 point applications, like that. We are going to create your surfaces. You have to define the points. Like that. Means these are all different applications. What is my intention? So much vast is there in CAD software. It is there, so much vast is there. But you need, they are going to give the basic training of the surface design, GSD as well as the wireframe and surface design. Then you can go for further applications according to your requirement. Here, you can make the models through surface design. And the bottom cover of the mouse, like that. Yes, yes. You are hearing?
Yes,
Hello?
yes, sir.
Hearing, no, sir? Okay.
Yes, sir.
Yes, sir. Let us, in Pro Engineer, the another model I show you, one of the good model. here. With the help of wireframe and surface design, the model is developed. See, isn't it? You can visualize the different parts according to your requirement. Almost all the shapes. How the parts are there, what are the other parts, how the model is done. All parameters you can visualize according to your requirement. And with the help of the wireframe and surface design, some part applications also, we are going for the concept development in the SolidWorks. See, this is also one model. Different models. You can hide the parts. You can see according to your requirement. How the parts are there, how the assemblies are there. Just I show the sections only so that it will be very easy to understand. You can have the sections. Yeah, you can have the sections, different planes. Yeah, like that. That's your requirement. You can give the values for the parts. All are going to develop. You can rotate it also. Yeah. Like that, you have got different parts. Here, this is also one of the engine part, the two-wheeler, isn't it? You can see here, according to your requirement. You can hide the parts so that you can understand the inside the parts as per your requirement. Different parts are there. See, so many parts. Here also you can take the section. I have the sections here. X, Y, Y, Z, Z, X. 3D file planes. 3D file planes. You can add it. See, so many parts are there. Isn't it? Z plane. See, see, so many parts. Like that, you can add the sections, you can rotate it, you can create according to your requirement. Like this, you can utilize your applications as per your requirement. Yes, so many options are there to create, to show any models. It will take its own time. So it is very difficult to show on the live project because sometimes because of the heavy models, we are not able to create it as early as possible within given time. You can add the material. Suppose if I have a solid model, you want to add the material, you can go for the adding the material for the solids. Suppose I would like to go for the cast iron, not cast iron, plastics only, but you can go for the different types of materials also. In metals, you have the iron. In iron, you have to go for the properties of the iron. Where you can define your Young's modulus, moment of inertia, and your density and other physical properties will be utilized for the material. Yeah. You can go for the analysis. isotropic materials, Young's modulus for this is Poisson's ratio, density is 7,870 kg per meter cube, thermal expansion, yield strength, all parameters can customize as per your requirement. Here, like that. Other parameters, the material, how object should be looked like this. Just you have to drag it and place it. It is going to take the material, apply material. Okay. Suppose you want to calculate the weight. You have to calculate the weight. Go for right click. Go to here. Select here. If I use the steel, it is around 0.135 kg, around 135 gram, like that. Suppose if I delete one feature, if I make one cut, automatically the mass is going to reduce. Suppose if I change the material also, it is going to vary according to your requirement, like that. You have to plan, you have to add the materials, other physical properties which will be utilized for the further applications. And after creating these type of models, any type of models, suppose monitors or any parameters, any models, how to manufacture it, that is very important. To understand it, I have a concept. Actually, I have thought of explaining tomorrow. It is the core and cavity design here and mold tooling design. Here we are going to extract the core cavity for any defined model, and here we are going for the keeping the mold base and mold base assembly and mold base, all these parameters with different catalogs, mold base, the mold tooling design. Yeah. Like that. You have got different mold base, injection side, ejection side, and other systems. I have planned to explain these things tomorrow. After creating the model should be manufactured. How to manufacture, how to extract the core and cavity. If it is a punch and die concept sheet metal component, how it is going to manufacture. Well, I have the plan to explain all these things tomorrow, and with CAM concepts also. If you have any queries, you can plan it.
Yes, if anyone has questions, they can type it in the chat box.
Yeah. Yes, basic surfacing I explained, and there's some models, hybrid design and combine together. I have made it. Yes, any questions? Yes. Yes. The question is, can you assess the possible places of the damage or faults in the designs using these softwares? Yeah. If you have made the assembly, and suppose if you want to, I have not shown that assembly design in detail. I have you can check the interfaces between the components. You can check the clearance between the components. You can check the clash analysis and draft analysis, whether draft is given to the model or not. All these parameters definitely we can check, even though some drafting errors, and all these parameters we can verify it and we can place it also. And if you give the wrong gate, and automatically you can plan it. Yeah. Most precise, up to 5 to 4 digits, we can give the accuracy. What is standards of unit? Unit means you can use in millimeter. We can go for customize all units and other parameters. You are going to get in tools on options. Now, in these options and standards, you have got standard catalog systems, other base systems, and other customized unit setup. In general, we have the units here. Parameters. In parameters, you can go for customize millimeter, kilometer, centimeter, angle is precision, and at time it's parameter, and mass its parameters. Like that, you have the measurement of units for all applications. As I have told, CAD is one of the top software. It's not like everything is given in the CAD. Think on that you are manufacturing on aeroplane. Everything, whatever the requirement, you can build in the CAD software. Yes? Any queries?
Anyone can ask the question. Any students or the faculty, please be free to answer the question.
I think all are getting whatever the things, technical things I am showing you.
Yes, sir, it was understandable.
Thank you, sir. Thank you. Yeah, some videos are pending to show you. Tomorrow I show you. Tomorrow I have the very good videos so that which inspires to understand and to get the jobs in the design. In design concept, initial struggle is required, but our graph is very good. If you compare the software engineers, our mechanical engineers with mechanical knowledge and software applications, graph rate is very good, very high graph if compared to software engineers also. So that here you can work on the production and quality control for 3 years, 4 years, 5 years. After that, or maintenance also. After that, you are going to get bored. Especially, it is not possible to work on the shop floor on quality control, other departments for the ladies. It is very difficult. But they have to choose the design and they have to make the career. There is a difference between job and the career. Job means you can become starts with the quality engineer or production engineer, production manager, senior manager, or factory manager. Career means you can have your own company, start your own design and consultancy, service industries. You can become entrepreneur by giving the jobs to your friend circles or can build the teams according to your requirement. Yes, any queries?
Sir, there is one question.
See here, the question is what the idea proposed to the designers. See here, there is a misunderstanding between the engineer's mind and the built officer's mind leads into development of a CAD software in the Second World War. And like that, there is any some development or innovative. Definitely, the ideas and other innovative views will be developed. Suppose right now we are boycotting the Chinese products also. We must have ability to manufacture. Initial struggle is required. The level of India and China, the products, if you go for the workers, the salary and designer salary also 4 to 5 times more than the Indian salary. Even though they have got some products, if person is taking 10,000 in worker in India, in China the same applications, the same production, he is taking 4 times more salary because they have made innovative things. So our intention is to work hard and we have to make new innovative things which will be utilized for the worldwide applications. Like that, we can have the development of new innovative things, reducing the cost. Definitely, we can boycott the other countries' products. We can make our own innovative development ideas. We can create great designs also. But the only thing is that the labor problems, we are lagging behind in the, even though we have huge resources, human resources, the labor problem is there. So that they are adopting the robotics. We also must have take the advanced technology, new robotics and other developments. Then we can minimize the product cost so that everyone is going to purchase. They are not going to purchase from the other countries. means innovative, yeah, with less cost we have to go.
Okay, sir. Thank you. If anyone has any questions, they can chat now.
Okay,
We can end the session.
projects here nowadays, the projects, the students projects give the industrial approach and innovative ideas is required. You must go for the mechatronics projects, electronics and mechanical. If you touch the software, that is better. Like that, if you go for the mechatronics plus software touch, if you do it, doing something help for your the career. Now in South freshers, only thing is you are recruiting through the projects what you have done in the final year or pre-final year. That is going to decide your job in the interview because before completion of your engineering, you must go for the one or two higher-end CAD software, one machine software, CAM and one software. Before completion of engineering, you must then you are to the the industries. Then you are going to get the good jobs. Yes, very.
Yes, sir. Thank you. I think we can end the session now.
Yeah,
And,
yeah.
we had a day of your workshop,
Yeah.
and it
Another
was
topic.
a fun session today
Yeah.
too.
Yes, sir. Yes, sir.
Yes, sir.
Core and cavity extraction,
And
the molecular design, camp. Yes, sir. Thank you, sir. Thanks for the giving opportunity for attending. Yes, sir.
yes, sir. Thank you, everyone, and we'll look forward for tomorrow. It will be in an even interesting session. We have another surprise for everyone.